I'm Doug. I'm going to show you how to actually use command line quaternions to make one of the animations that one sees at Visual Physics. Now let's just presume here that you've gone to the Downloads tab, you've downloaded the source right over there, and you've installed it, and it's passed the tests, and you did make install, and it's all kind of there. Okay, so let's go back to this main page here, and now you want to start to play, and I think one of the best ways to do that is to click on one of these things and just grab the command itself and start working with it. So this is a 3D space and one in time wire cube here, and for fun, just to explain, so we have the normal 3D cube, and then it's traveling in time to another set of 8 points where then you'll see the wire cube. Sure enough, come on, get there. And we're going to get the little blink. There we are. All right. Now we can do all kinds of variations on this, and one variation, here's the command itself right down here. Alright, so I have this thing called meta command, and the meta command will write out well, actually let's try and figure out what the meta command is all about. If you've never seen it, or you've never seen QGraph, or you're very confused about how to actually go forward. But the idea here is we're going to try and take the sign of a solid cube and see what it looks like. Now, to be honest, I don't have the slightest idea, and so this will kind of help you in that kind of process. So here we've got the Unix shell, and if you want to figure out, actually let's go ahead and put that command in here and try and figure out what it's really doing. Okay, so each one of these sorts of things. So the first thing is this thing called QGraph, and that's the thing that generates the animation. Then we have a bunch of options. Out means this is going to be the kind of name of it. It's called 4D wire cube, and for some odd reason underscores aren't showing up here. The directory it's going to dump it into is VP. Loop 0 means let's make this a loop. This says let's make it a box, and then we're using a meta command thing on something called the generate cube. Okay, so lots of things to try and figure out. So how are we going to figure out if we've never used this software before? Well, I have extensively gone and created man pages for all this stuff. I can't do a release unless oops, darn, there's a unless I've got a man page for it. And let me see if these show up. That one shows up. Okay, so that tells you how group QAdd works. But I also have, particularly for the Perl programs, written help pages. So if you put the -H, and I think, I see. I'm having trouble with where I stored the Perl module. So let me just go here, and I think it won't have any trouble. This is where I actually installed all my software, and I think if I go QGraph here, -help, yeah, okay, so so that has all these options. QGraph turns out to be my most complicated program for generating stuff. Alright, so so we've got this thing called generate cube. let's do the help on that. See what it says. Okay. So, to draw a square, you do generate cube, and you can set minimums, maximums. You can also do a pipe command on it, and then and just kind of you can set n, which means how many kind of points it tries to generate. And I found that you need at least 1,000 points in an animation to make it continuous. It's really easy to have n be small and have this little jumpy thing, but it's really kind of even harder to understand. So I try and make my animations look continuous. Okay, so we want to take the sine of a solid cube. So the first thing to do is to just work with how to generate the numbers, and then based on that, then once you have that, then you call the QGraph program. So the first part is just dealing with solid numbers, so we're going to deal with this generate cube thing, and we don't want to get that blinky aspect. So I think what we're going to do is that we're just going to set the tmin equal to tmax, and then we will move it in space-time by using a qadd n, a qadd n sort of thing, and that will get us a solid cube moving through time, and then we will take that cube and pipe it through the sine function, and we'll see what kinds of values we have using qsort. And if we can work all that stuff out, then we will go ahead and call QGraph on the thing. So that outline again: make the solid cube by making tmin equal tmax, do qadd n to move it through space-time, then pipe that into a sine function, see what it looks like with qsort, and to go from there. Alright, so we're doing generate the cube. Okay, and we're saying we're making tmin, let's make that -1, and the tmax equal -1. Time max -1. Alright, and just while we're starting out here, I like to keep it just a few points. Oops, unknown option. Okay, so oops, I see where I went wrong. I didn't put a minus option there. Alright, so that's what it looks like as a meta command. And I think we can do minus standard out, and it'll show all this. Don't worry about the warning. It's the intervals between these events are space-like, and it prints that out to standard error, but it's not really going to do anything. Okay, so we can see that we do get real, honest-to-goodness numbers. Okay, so the next thing we're going to try and do is to pipe this into a command. Let's see. Let's do it the official way. Standard out. We want to pipe this now into a command to move this whole thing along. Oh, and you notice, by the way, that all the here, where's my cursor? I've lost my cursor. Here's my cursor. Okay. All the that times are -1. That the times, sorry, the first number is always -1, and it's the x, y, and z values that are kind of going through these various changes. Okay, so we're taking this output and we're trying to do a qadd n, such that we kind of move along. So why don't we just add 1 to this thing, and let's do it 3 times. So qadd n will now take all that input, add 1 to it 3 times, and you can see we go from the -1. We don't see the -1 anymore. We see 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay, so it is doing like we expect. And if we now pipe that into a QSign function, sign, we'll go, oh, we get a bunch of different values. It's kind of crazy. So maybe this will look kind of crazy, which would be kind of fun. Okay, so let's see here. So how do we have to adjust this? All right, we have to adjust this. We have to get many more numbers. Okay, so let's do this as 1,000 numbers here. All right, so there are going to be 1,000 numbers in our cube. And let's move up. Actually, let's make this 500. 500 points in our cube. We're just guessing here as far as the numbers are concerned. And we'll do 500 steps. All right. So instead of adding, we want to go from like a -1 to 1. Actually, I usually use it either 100 or 1,000. Let's do 1,000 steps. Okay, so we're going to do 1,000 steps. All right. We're not going to change the X, Y, or Z values at all. We're just going to go from, say, -1 to +1. So we'll go 0.002. All right, so take 1,000, multiply it by that, and you'll get 2. And so we should go rather smoothly from -1 to 1. Okay. All right. So now to not actually look at all this stuff, because this is now 500 times 1,000. It's quite a bit of numbers that would flow by the screen, and you wouldn't be able to figure out what's going on. I'm going to throw it into a program called QSort. Okay, and I'm actually going to just look at the top of this, and the reason for that is that this QSort program puts the minimum and maximum values on the top and the bottom of of its output. I hope it doesn't do this warning thing 10,000 times, because that would be quite the drag. Actually, I don't know how long this is going to take, so we might be waiting a while. But this is what it is really like when you're trying to come up with an image that you've never tried to generate before, or anybody has in the planet. Actually, let's Control C out of this. All right, because we're just trying to, right now we're trying to get a ballpark. All right, so we're going to knock down the numbers in order of magnitude. And we'll just do 50 over here and give that a try. Okay, good. All right, now what we saw out of that is that we got these values that range from 2 in time, -2 to +2. So this doesn't look so bad. All right. All right. So, so I don't need the sort. I do need the sign. What I need to do, let's see. Is I've got this thing called pipe, which is supposed to be the pipe command. In other words, take this cube thing and and write this out. So let's just try this, see what it looks like. Okay, so we can see it's just writing commands, constant linear motion, 50 from these various points, piping it to QAdd by this kind of thing, piping that into sine. So I mean, the syntax of that looks right, and the way you can test that is you can simply copy this thing and paste it and see if it works. Yeah, it does work. Great. Alright, so is this enough points? I don't think so. We've got 100 points there. Let's just go for 300 and see if that's enough. But the important thing is that this is should be enough, as it were, for my command. So now I can go ahead. Actually, let me just do something here. We're going to make a directory for the output, and so we'll call it sine of cube. All right. So Q graph. All right. The output will be sine of cube, and the directory I wanted to dump into is sine of cube. Alright, that loop 0 is good. Minus box is kind of how big a volume in space-time I want, and we'll just do 3 on the side. And I think then, and then this is a meta command, because it's a meta command because it actually writes out the commands. The other way to do that is just just write the command. So there are just two classes of kind of programs I have for doing that. So, but this is a meta command. Meta command, and okay, so I think we need quotes around here. That's not going to fly. No, actually that doesn't look right. Does not look right. That's just like one side. Here is my meta command. Alright. Alright, so I'm going to put that thing in single quotes. There is kind of a trick or art to figuring out whether you use single quotes or double quotes to make this stuff work, but we'll see if it objects. Alright, check option, unknown option, meta unknown option. Okay, so meta generate. Let's see. Probably won't work. Alright, sorry, Q graph minus help, and let's pipe it to less. Meta command. It looks like meta. Should be the only. Darn it. Darn it, darn it. Let's see if it's an issue with quotes. So doubt it. Never know with these quote things, they can get kind of confusing. Check options. Unknown option. I can't thing to do is go back and see what this produces. Boom, 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 boom. It certainly looks right. Alright, so where there's a will, there's an irritation. Alright, so let's just grab this whole thing. Control copy. Alright, so let's go back. Sorry. Let's go back to one of these graph things. Get rid of the old meta. And I will look into making that work better. Control V. Okay. Go. Alright, so it is in fact drawing this thing. This is the output of point of view ray as it goes through and figures out all the points to draw and stuff. And this is very demanding on a computer. So this is actually running on a quad-core machine. I forget how zippy it is, but it's in a 2 gigahertz sort of range. It is a zippy box, and the zippier box is the better for this kind of thing, because no matter what animation you do, well, you know what you got to do it 100 times just to make a reasonable 10-second animation, and so far that's all I've specialized in is in 10-second animations. You can sometimes actually you can get a sense of whether you've got a good number of dots on the screen by how many little periods you see there, because I think it draws one for each little object it's dealing with. And there's a spot on the screen where it says like what frame number it is, but that's very hard to see here. I mean, I blew up the screen so that it would show up a little bit better on the screencast, not that I expect you to read it. So as I say, we just get to watch it generate these 100 frames. It's then going to make the kind of complex planes. Well, we're probably getting near the edge here. That's why it kind of blipped out a little bit. I mean, that's why it's making less. Alright, so now we've got 60,000 points that are part of this animation, and this is basically making the complex TX graph, I believe. Yes, you can see all the way that top line, it actually says what it's making. It's making sine of cube point, let's see. Oh, now it's working on, oh, okay, up at the top it says sine of cube point of view ray summary TY 100 with all that kind of that long name. Alright, so now we're doing the summary of the TY graph, and when we get done here we will move on to the TZ graph. Alright, so now we are in fact working on the TZ graph, and from there we'll work on the superposition. But this also gives you a sense of how long it takes to actually make an animation. It's not instantaneous because it has to do this ray tracing sort of thing. And in this case we're working on 60,000 points to make, as you can see up at the top line there, it says the superposition. And now we're linking the frames. This part unfortunately takes a bit longer than I would like. It's got the 100 frames and it's just making a GIF, what is it, 98A or 87A? I forget what it was. Now, why did I choose GIF technology? It's because I wanted to make sure that I had something that could be seen on all kinds of different browsers, and there just weren't like any open source alternatives. So given no choices, I didn't want to try and figure out codecs, and as I say, it really looked tough and it was hard to get it to show on browsers. I want these images to have global reach, so you know, it seems to work, so that's good enough. Alright, as I say, this step takes it unfortunately quite a bit of time, but when it's done we will just kind of CD to that directory and take a look at the animation by drawing up Firefox and giving it a whirl. And I honestly have no idea what this is going to look like. It's going to look like stuff moving around somehow, and somehow box-like, and but the details, which are important, really don't know. Okay, so it just said cleaning up. It's written this HTML thing, which is good. So let's just try Firefox on this cube point of view ray thing. No, it's on this sine of cosine. All right, see how it deals with this. And let's see. Oh, that's right. I think what I did. Gmail. There's this one. Okay. All right. So this is what it looks like. Oh, cool. Oh, reach a box. No, it doesn't quite reach the box, but it does shrink down. Oh, that is insane. That's why you should invest some time and effort here, because you never know quite what you're going to get. I wonder if there's any way to make this thing, you know, really square. I don't know. But that shows you the kind of wacko sorts of animations you can create by using the software available here at Visual Physics, specifically the command line quaternions. All right, thank you very much.